In chapter 2.1, we're going to talk about how to graph all the data sets we're getting. And when we graph all these data sets, what we're talking about is what we call descriptive statistics. And descriptive statistics is the branch of statistics that is concerned with the organization and summarization of data. When we organize data, we put it in a graph. And when we summarize it, we're going to analyze it with numerical values. So we have two types of data again. They are qualitative data, which is categorical or naming variables, and then we have quantitative data, which is going to be our numeric data, our counting data. And we have two types of numerical data, which are discrete and continuous. Discrete being it's countable, continuous being that it's measurable. So the first thing we're going to talk about here is going to be our qualitative data. And the graphical displays we use for qualitative data are the ones you probably know the best, which are a pie chart and a bar chart. So we'll start off with the pie chart, which is a simple graph. And we have this example where it says a physical therapist wants to determine the types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body parts requiring rehabilitation. And so you have all this data in this table right here. And we need to organize this data first. So the way we're going to organize is by creating a table ourselves. We're going to create what's called a frequency table. And in a frequency table, realize frequency just means how often something occurs. All right, and then we notice we have these different body parts: back, knee, shoulder, hand, hip, wrist, elbow, groin, and neck. And then the frequency is how many times are they occurring in each one of the data sets. So back occurs the most with 12, and it works itself all the way down to the neck, which has 1, the groin, which has 1, elbow, which has 1. So all we're doing is organizing our data right now. And from frequency, we get this other term called relative frequency. Well, the word relative means with respect to. And so we're finding the frequency with respect to the total here. And to find relative frequency is just another way of saying relative frequency is talking about what we know as a percentage. So this is just the percentage or how often something occurs with respect to the total. If you add up all these relative frequencies, here's how we calculate this first one, for instance. This 40% or 0.4 was found by there's 30 different body parts in there. We do 12 divided by 30. That equals 0.4. If you do 5 divided by 30, that equals 0.167. If you do 4 divided by 30, that equals 0.013. 2 divided by 30, 2 divided by 30, 2 divided by 30, 1 divided by 30, 1 divided by 30, 1 divided by 30. If you add up all these numbers right here, if you sum all these numbers, you're going to get a total of 1 or 100%. If you add up all the frequency counts, you should get however many counts you have in your entire data set, which was 30. The first graph we're going to use to graph qualitative data is going to be a pie graph. In a pie graph, we make a circle, and inside each circle we're going to section it off based off the percentage or the relative frequency of often something occurs. Now, if we're trying to be exact and draw 40% of a circle, we would need a protractor. So we're not really going to do that. We're going to talk about this thing called the slice size, and that's going to let us represent how big each slice is for each category. So if we're talking about back, for instance, we know back shows up 40% of the time. Well, I want to find 40% of a circle. How big is every circle? 360 degrees. So to find the slice size, you're going to take the percentage, such as 0.4, and you're going to multiply that by 360. If we multiply 0.4 by 360, we get 144 degrees. So that means that this back slice size is 144 degrees. And we can do knee, which came next, and knee is 0.167, so we would do 0.1667 0.1667, multiply that by 360, and I get about 60 degrees. So we'll round it up there, about 60 degrees. So you would do that for each one of these, and then once you do them all, they should add up to 360 degrees, or the entire width of the circle, entire degree measure of a circle.